Hello everybody, this is Pre-Calculus, Lesson 6 from Unit 8 about vectors. This is specifically going to be about vector applications. So before we get started, there was a warm-up, but I'm not going to do it. You should be able to do it. It was about the dot product when the angle between two vectors is going to be perpendicular. So you should have been able to go through that. You should have had some questions and homework. So if you did your homework, that shouldn't have been a problem. But before we get started on this lesson today, for our vector applications, we're going to do a quick review of law of sines and law of cosines. And remember, these two formulas are for non-right triangles. So you have your triangle on the left-hand side here. We have angle A, angle B, angle C. And remember, the law of sines says that sine of the angle A is to its opposite side, as sine of angle B is to its opposite side. So those are in the same ratio, or sine of angle C is to its opposite side. Law of cosines, remember, you can see here, whatever this side is, then the opposite angle is here. So if we were trying to find the length of side A, then you must have been given side B, side C, and the angle in between those two. And you would just plug in the information. The other thing I wanted to have a quick review about, because it's going to come up a lot in these vector applications, is trig form. So here's our trig form. Just to recall, trig form, again from the previous lesson. This will not be given to you. This will be given to you on the assessment, law of sines and law of cosines, but trig form will not be given to you. Really, it's just because that's polar form, right? If you want your x component and your y component, your x is just r cosine theta, your y is r sine theta for polar form when you're thinking about polar form, and your r is simply your what? Well, your r is the radius, which in this case is the magnitude of the vector. The length of that vector is magnitude. So again, this trig form will not be given to you, so you need to know that. All right, our first application. It says a plane is flying at a bearing of north 30 degrees east. We'll talk about what that means. At a speed of 400 kilometers per hour. In addition, there is a wind blowing 30 kilometers per hour due east. So letter A, it says model the situation using vectors P and W. The magnitude of each vector will represent the speed. So the speed of the plane is the magnitude, the speed of the wind is the magnitude. So let's see what's going on here. We have a plane speed of 400 kilometers per hour, and it is flying north 30 degrees east. So you're thinking to yourself, okay, I'm going to go north, but then I'm going to go 30 degrees east of north. So really you should be drawing a vector out here somewhere where this angle right here is 30 degrees, which obviously means that this angle here is 60 degrees. So the length of this vector is the magnitude. So the magnitude of each vector is the speed of the whatever it is. So this is the speed of the plane. So that's going to be 400 kilometers per hour. Then it says we have a wind blowing exactly 30 kilometers due east. So you can see your north, south, east, west. So due east is from here. It's going directly due east. And so what do we have? Well, it says specifically that it's 30 kilometers per hour. Obviously my scale is off here, but that's okay. So that length would be 30 kilometers per hour. And it says model the situation using vectors P and W. So obviously this is the plane, so this is going to be vector P. This one right here is the wind, so this is going to be vector W. The magnitude, okay, I already did that. So what is the plane plus the W, or plane plus wind? So we need to write that or draw that in here as well. So if we were to create a parallelogram, or we could have done tip to tail, it should have been directly across, right? So what are we going to have for the combination of those two? Well, that's going to be P plus W, which is your resultant vector, right? So that would be the situation. We have the plane that's taken off going 30 degrees north, 30 degrees east, and then the wind is pushing against it at 30, coming in at 30 degrees east. And so here, this green vector would be the plane plus the wind. Now write each vector in trig form. So there's a little reminder of your trig form. So we're going to have a vector for the plane, and we're going to have a vector for the wind. So you can pause and try that on your own, or you can do it together. One of the easy ways to do this is because you have the magnitude for each of these, we could, factor that magnitude out. So the magnitude is for the plane is 400. So I could factor that magnitude out. And then what do I have left? Well, I have cosine of some angle measure and sine of some angle measure. Now, here's the thing. What is cosine and sine of the angle measure going to be? Well, be careful here. This is where a common mistake happens. Remember, we did these angle measures at the beginning, where your angle measure always has to come from the positive x-axis, right? So we're going from east, directly east, up until that vector. So the theta that you're going to use for the plane is going to be 60. So you're going to have cosine of 60 I plus sine of 60 j. And now that I've demoed that for you, you could try wind on your own. Again, you have your magnitude, which is 30. Here, your angle is 0, right? So it's just cosine of 0 I plus sine of 0 j. If you didn't want to write it separate or factor out, you could, of course, oops, sorry, I don't know what I'm writing there. You could have just written them separately, 30 times cosine of 0 I plus 30 times sine of 0 j. That also works. So up to you. Both are acceptable. You could also, oops, I'm gonna run out of room here. Yeah, so again, you can factor it out like I did originally, or you can write it distributed. Okay, so it says the resultant vector represents the true direction and speed of the plane. So here I redrew this diagram. So here we have it. The resultant vector is this green vector, and that's your P, your plane plus your wind, right? That's your resultant vector. You can see that here through the parallelogram method, or you could have done tip to tail. So if we want to find the actual speed of the plane, that means we need to find what this magnitude is of P plus W. So in other words, we're trying to find the magnitude of P plus W. That would equal the speed of the plane. Okay, well then we're going to have to add P plus W. So you have it, I have to flip back on a different page, but you can go ahead and look at your previous example and add, well, what is P plus W? So go ahead and do that. I'm going to pause and look back at my notes, and then you can do the same and we can compare answers. All right, did you get 415.812 kilometers per hour? Hopefully you did. If not, let's check out why. So up here I rewrote what we got from our previous trig form. So this was the plane vector equation. This was the wind vector equation. So I took the I components, added them together, took the j components, added them together. And then cosine of 60 is 1/2, so that became 200. Cosine of 0 is 1, that became 30, so we get 230i. Sine of 60 is root 3 over 2, so that became 200 root 3. Sine of 0 is 0, so it just became 200 root 3j. Of course, we're finding the magnitude, so I need to square both of those components. 230 squared plus 200 root 3, the quantity squared. Take the square root of that, and that is what you should have gotten. Remember, the magnitude is the speed in this case. So you should have gotten 415.812. Now to do the second part here, hopefully you're saying to yourself, oh, this should be relatively easy. It says find the actual direction of the plane. Well, the direction is this angle from the positive x-axis to the resultant vector. So we're trying to find this angle. So if you recall, here we were going 30 degrees east of north. And so that means this entire angle here was 60, but that does not tell us what the angle is from the positive x-axis to the resultant vector. So we need to find that. But we can use what we just discovered here above to make it a lot simpler for ourselves. Remember, this is the horizontal component, so we're going to go right 230 kilometers, then we're going to go up 200 root 3. And so what can we do to find this angle right here? Well, hopefully you're saying to yourself, I can use tangent. Tangent of the angle measure is equal to the opposite over the adjacent, or y over x. And so if you were to plug that into your calculator, do inverse tan of that fraction, you should get 56.4177 degrees, or if you were rounding, you could have put 56.418 degrees. Now, that doesn't actually tell us the direction, so that would be 56.418 degrees north of east, right? So we're actually going 56.418 degrees north of east. Or maybe it's implied that if you write 56.418 degrees, that just implies you're starting from the positive x-axis and you're rotating that amount counterclockwise. There is a second example that is very similar to what we just did in the notes, but I'm not going to do it. We just did an example. You can refer to what we just did to help you with that second example. If you need help, getting the picture drawn or getting yourself started, then go ahead and ask your teacher. Remember, we also have tutors in the library, second floor up back in the left-hand corner. They can help as well if your teachers aren't available. So now we have our second application. So this one might be a little more challenging or a little more work, but we'll see. So another application of vectors represents tension on wires holding an object in place. The force on these wires can be viewed as a push or a pull on the object and is usually measured in newtons for metric or pounds for the American system. The magnitude of the vector will represent force. Now, I think we're probably going to present this a little bit differently than physics. I'm no physics expert, so you might have some conflicts. We were talking about it in our PLC about, how we're supposed to label things. I'm going to go with what's here. If you have questions, you can ask me or ask your teacher in class, or if you know it's not quite right because it's the physics, I don't know, just talk to your teacher. Okay, it says a 100-pound lamp is suspended by two wires. So here's your 100-pound lamp. Maybe it's a chandelier, not a lamp. Suspended by two wires. One is anchored from the ceiling at an angle of 20 degrees. So let's kind of look at that. So if we went across here, oops, I don't like that. It's not very straight. We went across here, right? So it's anchored at 20 degrees. So here I'm making this parallel to the ceiling. This is the ceiling up here. So my 20 degrees, if it's anchored from the ceiling, that's going to be 20 degrees, which if you remember back to your geometry days, your alternate interior angles, that's going to be 20 degrees down there as well. And then it says the other is anchored at 40 degrees, right? So we have 40 degrees. So I chose the one on the left to be 20 because I could tell it looked a little bit like a smaller angle. So the one on the right here is a 40-degree angle. Again, they're congruent because of alternate interior angles. So here's an image that represents this. So we have our two vectors here representing, oops, wrong color, the wires, right, that are holding up the heavy chandelier. And then you have this vector going straight down. So I believe that's what it talks about down here. It says, notice that the vector pointing south represents the weight of the lamp or the chandelier. It is pointing down because gravity is pulling it down, right? This happens in the real world all the time. So it's pulling it down that direction, so we have to figure out how to stabilize it and make sure it stays and doesn't crash down on anyone. So the other two vectors represent the wires. The pink and green vector represents the wires. This black vector here represents the 100 pounds that the chandelier actually weighs. So it says the length of the wire and the length of the magnitude, the length of the wire and the length of the corresponding vector are not the same, right? So the length of the vector will represent the tension on the wire. So the length of the vector is the tension on the wire. It's not actually necessarily the length of the actual wire that's holding that chandelier up in place, with the lamp up in place. So moving on, it says, in the previous picture, the two wire vectors are not drawn correctly. They must be in the direction indicated by the wire, but the resultant vector for these two wires must represent the opposite of the lamp, right? So it must represent the opposite because you're trying to counteract it and keep the lamp or the chandelier up in place as opposed to crashing down. So we're going to flip the direction of that. right, to kind of counterbalance it, I guess. So we're going to point that up here, and then that's the resultant vector. So if you were to draw your parallelogram, right, you can see I've drawn that over there to the right. Then that opposite of L, or negative L in this case, is the resultant vector in this particular case. So then we know this statement to be true, that the wire tension, or number one, the vector of the wire one plus the vector of wire two equals the opposite of the lamp, right? So W1 plus W2 equals negative L. Now, instead of really writing, well, let's just keep going, sorry. It says, the magnitudes of the wires represent the tension on each wire, and it will be easier to solve if we make the magnitude of wire 1 equal to capital letter A, or some kind of variable, and the magnitude of wire 2 equal to B. So just keep that in mind. It says it a little bit later in the notes, but I went ahead and put it now because I think it's going to be easier if we do that earlier on. So it says find all three vectors in the equation above, and then we're going to write each in trig form. So we're going to find all three vectors in trig form. So what do we have? We have wire number 1, right, which I did in pink, and we have wire number 2, which I did in green, and then we have the lamp or the chandelier vector, which is in black. So I'm going to start with that one because that one's a little bit easier. Since we reversed it, instead of doing this negative L, well, let's just look at this negative L, right? What is it doing? It's going directly up. There is no horizontal component. There's only a vertical component. So you're going to have 0I plus 100J because it's just going directly north. And the weight is what its vector or its magnitude is. So it's just 0I plus 100J. Then let's do the green one because that's going to be the next one that's easiest, and then the pink one we'll have to talk about. So the green one here is pretty straightforward. We're trying to find this magnitude of this green vector. We're trying to get it in trig form. So we need to find, remember what is trig form? That means we take the magnitude, which we're going to call B, and we distribute it through the horizontal component and the vertical component. So the horizontal component is cosine of the angle measure I, and then the vertical component is sine of the angle measure J. Now that angle measure was really simple. It was just 40 degrees. So this is what your trig form would be for wire 2. Now for wire 1, I'm going to present two different options. And I think in physics, you might have some other way of doing this, and it's totally fine. If you take physics and you're like, I know what you're talking about with sleep, well, I don't even need to listen, I do this a different way, that's fine. As long as we're getting the same answer, you can do it in a different method. It doesn't matter in terms of what I see on an assessment. As long as you are justifying your answer and I see work, it's all good. Okay, so wire number 1, you might immediately say, oh, well, that's easy. The angle is going to be 20 degrees. So yes, you are correct. You can use the 20 degrees, but you have to be careful if you choose to use the 20 degrees. You have to realize that this right here, this is the origin. And if we're using 20 degrees, well, our horizontal component is going to the left. So if I'm going to use cosine of 20 degrees, then because I went to the left, I have to make this particular part, I have to make it negative, right? So this negative sign right here has to be included because I went left from that origin, or from where we're having that center point be, that origin point. So be careful. Yes, we can write negative A cosine of 20I. And then because the sine value is going up, it's going to be positive anyway. So we can write A times sine of 20J. So that will be just fine. Or perhaps the more proper way of thinking about it is that you are technically supposed to start from this positive x origin over here, and you're supposed to rotate, and that's supposed to be your angle that you're using for theta. So another option would just be to have A times cosine of 160 degrees I plus A times sine of 160 degrees J. Again, does it matter? No, you're going to get the same answer. Negative cosine of 20 is the same thing as cosine of 160. Those are going to produce the same answer. Try it, plug it into your calculator. You're going to see it's the same. So you can decide which one you're going to use. I'm probably going to use this top one, but again, up to you. Yeah, we're going to move on. Okay, so the next part says, let's solve for A and B. So our ultimate goal is to calculate the value of A and calculate the value of B. Well, how are we going to do that? We're just going to create a system of equations here, right? So we can see that if we take, if we know, sorry, let's go backtrack. It says we know that, oops, I want to use the highlighter. We know that W1 plus wire1 plus wire2 has to equal the opposite of L. And this is the opposite of L, so if I put the negative in front of it. So that is the opposite of L, or negative L. So now we just have to add them together, right? So if I add negative A, again, you can use this one or you can use this one. So I'm going to add all this up, negative A cosine of 20I plus A sine of 20J, plus B cosine of 40I plus B sine of 40J must equal 0I plus 100J. Well, what can we do? Hopefully you're saying if we put the I components together, it needs to equal 0. And if we put the J components together, then it needs to equal 100. So what would that look like? Well, I could say I cosine of 20, or sorry, A cosine of 20 plus B cosine of 40, I has to equal 0I. So basically, A, and sorry, that's a negative A, my bad. A cosine of 20 has to equal B cosine of 40, right? So now I'm just, these two have to cancel each other out and equal 0, which means that one has to equal the other. And so I can isolate A. A is going to equal B cosine of 40 divided by cosine of 20. This is what A equals. On the other hand, right, I can say my A sine 20 of J plus B sine 40 of J has to equal 100J. So A sine 20 plus B sine 40, right? That has to equal 100. So, well, I can just take this piece right here, oops, this piece right here, substitute it in for A, and then isolate the B and solve for B. So go ahead and do that now. Pause and try it on your own. Okay, did you get A equals 88.455 pounds and B equals 108.506 pounds? This right here is what you should have put into your calculator to calculate the value of B. Right here is all the algebra. I substituted this in here. You would factor out your B. Maybe it showed a little bit better in the answer key, I'm not sure, but factor out your B. So then you would have to divide by cosine 40 divided by cosine 20 times sine 20 plus sine 40. So that's just all algebra, 100 divided by that. And don't forget, you need to label. So these were pounds. LBS is pounds, right? So we're labeling. So the tension on the wire 1 is 88.455 pounds, and the tension on wire 2 is 108.506 pounds. There is an example 4 that's very similar. I'm not going to do it. So now that I've done this one, you should be able to go ahead and work through that problem on your own and check the answer key. I hope this helps. Of course, stop in and see your teachers for questions. If we're busy, you can always find the adults in the library in the back left-hand corner. Bye.